This is section 8.5, problem 5, the last problem in this section that we're going to look at. What have we got going here? In this problem, assume that the distribution of differences is approximately normal. All right, so we'll assume we've got a normal distribution of differences, one population minus another one. Note, for degrees of freedom, not in the student's t-table, we're probably not going to have to worry about that because we can use our calculator to run these tests. Now, anyway, let's go down here. What have we got? Here's the question. Are America's top chief executives, CEOs, really worth all that money? One way to answer this question is to look at row B, the company's annual percentage increase in revenue, versus row A, the CEO's annual percentage salary increase at that same company. All right, so here is the percent increase for the CEO. Here's the percent increase for the company. Now, here's the question. Well, suppose a random sample of companies yield the following data. Okay. Now, do these data indicate that the population mean percentage increase in corporate revenue is different from the population increase in the CEO salary? That means here's the increase in the salary. Is there a significant increase in the company's increase? Part A here says, what is the level of significance? They're going to tell us that, 0.05. So we're going to run this at 0.05. Now the next part, state the null and alternate. Let's go to the alternate. What is it we're testing here? See, the alternate has a greater than, equal, not equal to, less than, or equal. Well, it's not going to be equal. So what are we testing here? It says, did these data indicate that the population mean increase? All right, so we want an increase of B over A. All right, so we want an increase. So we're going to be testing this one right here. So the null is going to claim that there's no difference, right? That there's no difference versus that there is a difference, a positive difference, an increase. Question B says, what sampling distribution will you use? Well, let's see. We are assuming that these are normal. So I think we're going to be using student T. Student T, we assume that D is approximately uniform. No, that's not it. Let's see. We're going to use the student's T. Forget the normal. This is the only one left. The student's T, we assume that D is approximately normal. Yes, they're telling us it's approximately normal. We have small samples. Now, what's the value of the test statistic? Let's put this in our calculator and have it do it for us. So let's put this data into list 1 and list 2. All right, so here's what we're going to do. We're going to go to list 1 and list 2. Well, that's a list 1 and a list 2. Okay, and actually, do you remember how to get there? Let's just do it here. All right, so list 1 and list 2. We're going to go to Stat, over to Edit. Well, I guess it's just down to Edit, right? Just down to Edit. And then you're going to see L1, L2, bunch of lists. Okay, now you may have data in there already from list 1 and list 2. So you want to clear that data. So what do? Get your cursor in list 1, use your up arrow key and get it all the way up to L1. Press clear and enter. And then all that data out of list 1 disappears. Run your cursor over here to list 2, run it all the way to the top, highlight L2, right? Get your cursor on the top, press enter, and then press clear, enter. All that data disappears. All right, so all the data out of L1 and L2 is now gone. Now, you're going to get your cursor back into L1, and you're going to start putting in data. Now, the question is, what data do we put into L1, and what data goes into L2? And what are we going to put in L1? Are we going to put B or A? Well, the way we're looking at this is this. We want to know if there's an increase in the company's yields. So if there's an increase, it seems like B should be bigger than A. So why don't we put in B, and then it would be B minus A. So I'm going to put B in here. All right, so I'm going to use this one here for B and this one for A. So put in the B numbers. So go ahead, I'll read them down. It's going to be 22, enter, 25, enter, 27, enter, 18, enter, 6, enter, 4, enter, 21, enter, 37, enter. Now right arrow over to list 2, and we'll put in A numbers. I'll read them. It's going to be 21, enter, 25, 22, enter, 14, -4, 19, 15, and 30. Now remember, the numbers are paired, so be sure that you get them in the correct order, right? As you go down your list, make sure this one goes with this one with this one, right? Down, and the same ones down like this. Now we're looking at paired differences. Probably should have done this before, but we need a list 3. So if you have data in list 3, get it out, right? Put your cursor in list 3, use your up arrow, get it right on L3, press clear and enter, so that list 3 is now clear of data. Now, get your cursor in list 3, up arrow until you get to list 3, right? Get your cursor on L3. Put your cursor on L3. Now you have to go get list 1 and list 2. So here's how you get it. Get your cursor on L3 and then press second numerical key 1, or I'll write it down here. Well, okay, I'll write it here. You're going to press second and then the numerical key 1. That'll get you L1. So you press second 1 and then L1 comes in. Put a minus sign. Press the minus key. Then press second and 2. And then L2 comes in. So what you're showing now, hopefully, is L1 minus L2. Now press enter. When you press enter, the calculator automatically computes all these differences. I mean, it'll take 22 minus 21, so you should see a 1 there, right? 25 minus 25, you should see a 0. It just makes all those computations for us. Now we're ready to do our hypothesis test. So where are you going to go? Well, we know. You go to Stat, over to Tests, and what you want to do is select item number 2. We're running a t-test, right? We're not doing 2 samples or anything. We're just going to run the test on L3. So we're going to run a t-test, so select number 2. Now, we're inputting data, all right? So what you want here is data, because it's going to choose from L3, data, and then mu naught is what we're testing. That's 0, right? That there's no difference. Type in a 0. The list that we want to use here is list 3. So how do you get it? You press second and the numerical key 3, because right above the 3 is L3. Right? So put a 0 for mu naught, L3 for list 3. Frequency is 1. Now we're doing a greater than test, right? We want to know if these numbers here are greater than these numbers. So they should be positive, right? That B is greater than A. So put your cursor over here on the greater than, enter, go down to calc, and enter again. So we'll calculate. Here's the important data that comes up. It reminds me again that I'm doing a greater than test. It gives me the T star value. Now, did they ask us for that anywhere here? Well, not in this part here, but if we were doing the critical region approach or the traditional approach, we would need that T star. They might ask that in the next part over here. I couldn't get the whole question on. But they do ask us for the p-value. All right, so what is the p-value here? Oh, no, they do ask us for the, right down here. What is the value of the sample test statistic? That's this one right here. All right, so let's go with that. T-star is 0.83, round to 3 decimal places, 0.830. And now this part here, C, says find or estimate the p-value. Well, look at our p-value here. Think of it as percent. It's easier for me to see it as a percent. It's about 21%. Right, 21%. Where is that here? This is greater than 50%. This is 25% to 50%. This is 10% to 25%. I think that's where we are, right? We're at 21%, so we're in this interval. All right, we're between 10% and 25%, because we're at 21%. So let's go here. Where is it here? Right there, 21%. And now here's the rest of the problem. It was just so long I couldn't get it on one page. So now what they want us to do is to sketch the sampling distribution. Well, what are we doing? We're doing a greater than test at, well, I forgot the alpha value. I have to go back and get it. Watch your eyes here. So we want alpha, okay, I'm going to read through the problem here. Oh, right down here, 5%. Okay, so let alpha be 5%. And they even told us, use B minus A so we get positive values. All right, so back to the next page. All right, and what I want here is alpha equals 0.05. So what's the proper distribution? So first of all, it's a greater than test. So it's a right-tailed test. So it's not this one. That's two-tailed. It's not this one. That's a left tail. This one says I have a right tail, and look at our t-value, 0.8. What is it over here? Well, there's 0. That's 2. That's probably 1. That's probably 0.8. See, you've even got more than 50% of the area here. It's not that one. It's going to be this one here. So let's go with that one. Now we've got our p-value. So, of course, that's what we're going to use to determine if we should reject or fail to reject. And I'm going to do it by my little table here. I'll make a comparison. 0.2169. How does that compare to 0.05? Well, 21% is bigger than 5%. And if it's bigger, do you remember what to do? We fail to reject H naught. Okay, so we're not going to reject H naught. So what are we going to do over here? The first one says, since P is greater than alpha, we reject H naught. Well, that's not true. We're going to fail to reject H naught. Since P is less than alpha, that's not true. P is greater than alpha. Since P is less than alpha, no. This has got to be it. It's the only one left. Since P is greater than alpha, we fail to reject H naught. So the data are not statistically significant. That's correct. If the data is not significant, we don't reject. If the differences are not significant, we don't reject. So we're going to go with this last one down here. Now we're not rejecting H naught. So now what do we do down here? Well, let's see. We're failing to reject. So let's get rid of this. That says reject. Get rid of that. This says reject. Get rid of that. So it's going to be one of these two. Fail to reject H naught. Okay, at 5% level of significance, the evidence is sufficient to claim there is a difference. Well, that's not true. We're saying there's no statistical difference. We're failing to reject. So there is a numerical difference, but it's not significant. So I'm assuming it's got to be this one. Failed to reject. At 5% level of significance, the evidence is insufficient to claim that the difference in population mean percentage increase for corporate revenues and CEO. All right, so we're going to go with this one. Where is it? Right there. And I think that finishes this problem.